Okay, so today we're going to talk about how to simplify a square root. In our next unit with Pythagorean theorem and special right triangles, it's going to be helpful for us to understand how to do this. So I thought it'd be a good time to just kind of take a review day and kind of review how to do this. So first things first, the square root is just a number. The square root of a number is a value that when you multiply it by itself, it gives you that number. So for example, I've got a list of my perfect squares here. So 1 is just 1 times 1. So since 1 times 1, it's choose the same exact number, multiply by itself to get to that number. So when I take the square root of 1, my answer is just 1. 4 is 2 times 2. So if I say, hey, the square root of 4 is equal to 2. Now you learned in Algebra 1 that technically the square root of 4 is 2 and negative 2, but since we're in geometry and we're talking more about lengths of sides and stuff, we're going to just worry about the positive version of it and not the negative version. So, and to kind of keep going down here, 9 is just 3 times 3. 16 is just 4 times 4. And then 5 times 5. And then we have 36, which is 6 times 6. 7 times 7. 8 times 8. 9 times 9. 10 times 10. We have 11 times 11. 12 times 12. 13 times 13. And then, we have 14 times 14. One that kind of got off the, looks like one of them, there's 225, which is 15 times 15. I thought at first maybe I missed that in my picture. So, like the square root of 9 is just one of these three. So 3 times 3 is 9, but the square root of it is just 3. So I'm going to go over a couple different ways on how to simplify your square roots. You can pick whichever way you like better. I definitely have a preference for one of them, and then, but if you think differently than I do, that's okay too. So one of the ways that I'm going to show you how to do this is we're going to do prime factorization of the number, and then we're basically going to be looking like for these pairs and circling them. So what I mean here is like if I do 24, numbers that multiply to 24, you can pick any of the numbers that multiply to 24. If you want to pick 4 and 6, 8 and 3, 2 and 12, it doesn't really matter. So I'm going to go ahead and pick 2 and 12. But again, we get to the same end result regardless. 12 is 2 and 6, and 6 is 2 and 3. And again, for 12, you could have picked 4 and 3 with that as well. It doesn't really matter. So 24, I'm going to write out my prime factorization next to it here, is just 2 times 2 times 2 times 3. So now if you think back over here, we talked about how your perfect squares, like we have 1 times 1, 2 times 2, 3 times 3. So I'm going to go ahead and circle any sets of 2 numbers that I have, since we're looking for a square root, which is looking for 2 numbers. So I've got one set of 2's. Now, we talked about this over here that when we take the square root of, like, say, 2 times 2 or the square root of 4, your answer is just one of those numbers. Like, it's just 1, 2. So when I circle my pairs, I'm circling my perfect squares that are in the number 24. So when I take the square root of 2 times 2, I'm left with just a 2. Now I have no other pairs, so everything else needs to go back underneath the square root because we can't take the square root of it. 2 times 3 is 6, so I'm going to leave that as 2 square roots of 6. The second one, so we're going to do the same thing for 12. So I'm going to go ahead and do my prime factorization for 12. Again, you can do 2 and 6, or I'm going to do 4 and 3. And then 4 is just 2 and 2. So here, 12 is just equal to 2 times 2 times 3. Again, I'm looking for my pairs, so I have one set of 2's. When I take the square root of 2 times 2, I get 2. And then I've got my leftover 3 that needs to go underneath that square root symbol. I'm going to do one more, the prime factorization way, and then we're going to talk about looking for perfect squares in numbers and breaking numbers apart that way. So 48, so I'm going to scooch over here. So 48. 6 times 8 is 48. 3 times 2 is 6. 2 times 4, and then we have 2 times 2. So 48 is equal to 3 times 2 times 2 times 2 times 2. Sometimes when you're doing prime factorizations, once you get your factors, it might be helpful to like cross off your numbers so that you don't count them in to your prime factorization, because sometimes students will do that and end up with extra numbers. Alrighty, so I'm going to go ahead and circle my pairs. So I have 2 sets of 2, so I can write the 2 once and then write it again twice for the second set. And I have a 3 that's not circled, so that goes underneath my square root symbol. 2 times 2 is 4. So the square root of 48 can be simplified to 4 square roots of 3. Okay, so if you like doing it that way, great. You don't have to listen to the rest of the video if you don't want to. But there's another way too of looking for perfect squares in numbers. So this is where also the list of perfect squares comes in handy. So 75, we just need to kind of think about, well, what numbers will multiply to 75? And hopefully we can figure out factors, one of which being a perfect square. So since I know that 75 ends in a 5, I'm actually going to go ahead and do 75 divided by 5, and I get 15. So neither of those is perfect squares. If I do, so one of my other division tricks, if I add those digits together, 7 plus 5 is 12. 12 is divisible by 3, so I know that 75 is divisible by 3, and I get 25. So 75 then is equal to 25 times 3. Now, 25 is a perfect square. 25, the square root of 25, we can kind of split them up this way. The square root of 25 is 5, and then we can't take the square root of 3, so I'm just going to leave it underneath there. So the square root of 75 is 5 square roots of 3. So for this method, you do kind of need to recognize and know your perfect squares. You also then kind of need to have pretty good idea of your factors, or not be afraid to use your calculator for the factors. Oftentimes, if you divide by 2 or by 3, a good chunk of the time you will probably get a perfect square out of the deal, but not always. So sometimes I just kind of start with 2 or 3 and then just kind of work my way up until I get a perfect square. So like 180, if I divide that by 2, I get 90. It's not a perfect square. 180 divided by 3 is 60. 60 is not a perfect square. It's not on my list. So 180 divided by 4 is 45, and that is also not on my list. 180 divided by 5 is 36. 36 is on my perfect square list, so I can rewrite this as 36 times 5. I can split them up. I don't always write them out split up because that just kind of takes time. But your square root of 36, if I look over here, is 6. And then I have a 5 left over. So there you go. And then last but not least, so if I do like 500, if I divide that by 2, I get 250, which is not a perfect square. Now 500 divided by 5 is 100, and 100 is a perfect square. So that's just going to be equal to 100 times 5. Oops. Sneak in the 100 there. Your square root of 100 is 10, and then we have the 5 left over. So you may pick and choose which way you like best. Personally, I like doing my factor tree because I can pick any 2 factors, and I don't have to worry about finding a perfect square. If you are somebody who sees numbers a little bit better, or you're not afraid to use a calculator to kind of keep trying something if the first thing doesn't work, and you know what your perfect squares are, or you're not afraid to have this list handy, this may be just as easy for you, doing your perfect square way. It doesn't really matter to me, just as long as you get good with simplifying square roots.